Alright, so this is a video that's going to show you how to apply some basic calculus to solving some equations. We'll be doing some differential equations. Reference your advanced placement physics equations chart. Specifically, we're going to be using this relationship here. So I had given you the equation I wanted you to deal with, and that was t squared plus 2t minus 3. And again, we'll be applying the shortcut method of differentiation, only instead of x being here, it's t. We're going to be differentiating with respect to t. Right, so we're going to take this and put it into this form, dx dt. But instead of x, we're putting in that equation for t, or with t. Remember, dx dt is equal to v by definition. So turns out that when you have multiple terms within a differential equation, you can just separate them out like so. So dt squared dt plus d 2t over dt plus d to the negative 3 with respect to t. For this first one, the n that we have is actually 2. So we're going to bring the 2 in front and then subtract 1 from that. So it looks like this. 2 times 1, t, 2 minus 1. For this one, the value of n here is 1, so we're bringing the 1 out, multiplying it, and then subtract 1 from that. And it turns out if you are differentiating a constant, it's just 0. So this simplifies to that. So the velocity is equal to 2t plus 2. And then I'd ask you to differentiate again with respect to t. So take dv dt, which by definition is acceleration. So that equation goes to this form, and it differentiates like so. So as a way to continue applying this, remember I had a little over a week ago assigned problems 15, 16, 17 in the textbook, not realizing that most of you hadn't gotten to derivatives yet in your calculus class. So I'm going to look at number 15, and I will do the first part, and I want you to try out, keep practicing, do 15, 16, and attempt 17. So the question is, what is the velocity at t equals 1 second, and they give an equation for position. You're going to differentiate that equation with respect to t. So it looks like this. Velocity is equal to dx dt. So I'm bringing this down. Remember, taking the derivative of a constant is just a 0. So from there, this term becomes that. This term becomes 12. And it simplifies to a velocity of 6t minus 12. And at t equals 1 second, we're going to end up with a velocity of minus 6 meters per second. So keep going, try out the rest of those problems. Going back to the previous problem that I had where you were dealing with this, just so that you keep the big picture in mind, the derivative is really in truth the slope at any one point. So if I take the derivative of this equation here, this equation makes this shape, then in essence I'm calculating the slope at every single point. So here it's a negative slope, so we have a negative value here. At this point it becomes a positive slope, so that goes positive. When I go through and take the derivative of this equation, I get the slope, but it's a constant slope, so the acceleration at every point is 2.